Our Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
3.
Main engine start.
Good evening, everyone. Welcome to the event horizon here on Astronomy.fm radio. It is another Friday night. This one is July the 27th, 2018, 9 o'clock in the evening. For those of us here in the eastern portion of North America, 1 o'clock in the morning, Saturday morning, Universal Time. And of course, we welcome everybody into our Astronomy.fm chat room right now. Come on over. That's where all the action's happening. You can still go back to our homepage, Astronomy.fm. And, well, if you're listening to us, you know how to click on the radio there. But you can also get into our chat room. There's a link there, too. Still working on the replacement chat. We've got the temporary chat room. The temporary homepage up. Still working on the new one. So that's coming along.
I just need to make a quick comment here before I officially introduce myself. Evil Spock says, IPA in hand. Shall we begin, Mr. Kirk? Yes, Spock, we shall begin. Okay, yes, it's me, Nick Vets, 2 Echo 0, Lima, Uniform November. And I just want to say hello to everybody in the chat room. We've got Aqua for You, myself, Marty, Starstorm, Glenn, Twisted Edge, Cassie, Redshirt 3, and, of course, Evil Spock. And it's nice to be here.
It's nice to be anywhere.
Well, it's always nice to be in Margaritaville, too.
It is, but we're not in Margaritaville.
That's debatable. And as Starstorm, come a little bit closer. Say it.
It's always 5 o'clock somewhere.
There you go.
But anyway, yes, it is nice to be here tonight. I know we're still having the odd problem with our primary server, but that hopefully will soon be fixed. Mm-hmm. We are putting. I'm putting a workaround together at the minute. I'm going to try and put this show and Comet Watch on my YouTube account. I will post links on the AFM Facebook page so that people can find it. So if you're listening after, I would say it may be a few days later. You can definitely get the podcast and the links together because it's going to take me a little while. This is all new territory to me. Turning a podcast into a movie to convince YouTube it is a video, not just audio. So you won't see us. You will see our logo, which I will nick from the AFM website, AFM Facebook page. But you'll be able to hear us, and I'll be able to get some links up and everything. So at least something like reasonable service is back. Servers are a pain, I know. Unfortunately, ours is being a real pain. Personally, I would rather take it out and shoot it and perhaps put up a new one, but not Michael. Sorry about that. Of course, we could always use M5 or HAL 9000, and then the computers will be trying to take over the show.
There you go. Or what were some of the other movies about computers taking over the world? What were some of those old sci-fi ones?
The Colossus, the Forbin project.
Colossus, yes, I remember that one. Yep.
Because it decided to talk to its opposite number in Russia, Peter the Great,
mm-hmm.
and they decided to run the world between them.
Mm-hmm.
Unfortunately, there was a nuclear exchange, and the American missiles did actually get through, but not the Russian ones. Oops.
And there was, what was there one, something about computer games? Is that what it was called too?
War Games.
War Games, that's it. Yep.
That was oh god, that was what, the 80s, early 80s?
Yeah, something like that.
And it's teaching a computer the fact that it can't win. There isn't no such thing as a winning scenario. I suppose, given the opening comments I made to Evil Spock, one has to say this is kind of like a Kobayashi Maru test. Oh, Skynet, yeah. That was controlling all the cyborgs. Hasta la vista, baby. But as I say, Kobayashi Maru don't believe in the no-win scenario. Well, I suppose there's always a way to win if you can cheat.
There you go.
By gosh, James T. Kirk knew how to pull it off with panache and style.
There you go.
Much better than Picard did, I think.
Mm-hmm.
But as I say, it's nice to see Glenn back in our chat room. Westworld, yeah. The androids went amok and started killing the humans, yeah.
Mm-hmm. Some Star Trek episodes 2M5. What was that one about? The Daystrom.
That was Richard Daystrom's latest all singing, all dancing computer.
Mm-hmm.
Kirk got called Captain Dunsel.
Mm-hmm.
And in the end, they managed to deactivate it, and Kirk left himself wide open to being blown out of space by the opposing starships.
Yep.
So
talked him out of taking over.
Yeah.
Somehow.
Well, of course, there's also SAL 9000 in 2010, the sequel.
Okay.
To 2001. I always felt sorry for Sal because she always missed Hal in reality, and she was a little bit dubious about the experiments to try and duplicate what would happen if certain modules were removed and then put back into place, as they were going to do on the USS Discovery. Yeah, sad, isn't it? I really did know my Star Trek. I own the original series on. I have it on Blu-ray. And I have to admit, I like the new effects, even if Bill Shatner doesn't. It's a lot more realistic. The phasers now track. The Enterprise is made to look more realistic size-wise against the planet in a lot of the planets.
For the distance that it should be orbiting at. Yep.
Yep. Holly was a hologram, and that was replaced by Rimmer.
Was Holly even a hologram, or is Holly just a video?
She was She was the ship's hologram.
Yeah, but she wasn't 3D.
No, but then later on in the series, Rimmer replaced her with a hard light unit. But that was Star Trek Voyager. That's how the emergency medical hologram actually managed to get around the Enterprise. Mm-hmm. Well, not the Enterprise, the Voyager. But according to Voyager, all the other Federation starships had their own emergency medical holograms. But
that's right.
As I say, it's just one of those things. Computers in space, rogue computers in space, never any good.
At least not in television and movies.
Yes, Evil Spot. The remake of the Doomsday Machine. I think when James Crowley and his team at Lake George, they really went to town on the Doomsday Machine and bringing back various incarnations of the Enterprise, etc. And of course, seeing the original Christopher Pike, or an actor so close to the original. I think it was Jeff Hunter that played him in the original pilot.
Yep.
And that was awesome. The various time jumps, Kirk and company.
I haven't seen the original.
So I guess it would be a mock time. It was one of my favorites because it let us see a little bit more of Vulcan.
In a mock time? Oh, yeah, I think so.
Yeah.
I haven't watched the original in quite a long time, so I've kind of lost most of the trivia on it.
Yeah. Piece of the Action was a good story because they were setting the ship that had called in on that planet had left a history book of Chicago, and the whole culture became a 20s and 30s gangster culture. Mm-hmm. I never really cared for the like mirrored culture, not mirrored, but similar cultures of like Earth on another planet with the same, history. Like, what was the one with the cons against the Coms and the Mercs?
Yeah, I didn't like that because that parallel universe, parallel universe stuff, just not going to happen any way, shape, or form. So, no, they should not have any type of American or Earth culture on another planet at all, without some influence like the gangster one that had influence.
Well, the thing is, what was interesting was, if you read, I think it's Preserver. It's a Bill Shatner Star Trek novel.
Okay.
They actually make an attempt to explain why there were planets that so closely mirrored Earth.
Mm-hmm.
Because what the Preservers were doing, they were seeding cultures and seeing how they developed. So they took old Earth cultures, put them in a new place, and allowed them to develop without interference. And it was kind of an interesting experiment, an anthropological experiment. There's a big word for you this early in the show.
There you go.
But it allowed... Well, the book explained it very quickly. The fact that the reason the mirror universe, where they're all Nazi thugs, basically, was able to interact was because the Preservers messed up, and in reality they were trying to destroy the mirror universe.
Ah, that was the evil Spock one.
The evil Spock, the evil Kirk.
Okay, well that I could accept because that was supposed to be another semi-parallel universe. I could accept that, but not like in the same universe with similar cultures that Earth went through, and then they took a different path. It's like, no, that doesn't work that way.
Well, as I say, the thing is, with some of the Star Trek novels that Bill Shatner co-wrote, they actually make the attempt to explain.
They came up with why that happened. Okay.
Yeah, he came up with a very good explanation of why there was at least 3 planets where they were, in some degrees, parallels to Earth. One was a complete disaster where the children, once they when they got to puberty, several centuries, died very rapidly. It was a biological warfare experiment.
Miri,
yeah.
Yep.
The Merricks and the Khans episode, the Omega Glory, again, it was a failed Preserver experiment.
Okay.
And where they're trying to deflect the asteroid from a planet inhabited by Native Americans. Pre.
That was a different episode of Native Americans.
Yeah. That again was another Preserver experiment because they had the Observer Obelisk, which was used to deflect any asteroids that would impact. Kirk and his team had to figure out how to get in there and fix it and make it work because the Enterprise on her own could not use its deflectors or weapons to destroy enough of the asteroid to deflect it.
But they're supposed to have enough weapons to destroy a planet, so it kind of makes you wonder on that one.
Well, yeah, it's one of those weird things. They talk about phases, but one of the things they did explain, I think, that a lot of the canon novels that were actually based on some of on stuff that was said by Roddenberry to be correct for the various incarnations was it in some cases to crack a planet it took multiple starships.
Okay.
So using you would have to use all your photon torpedoes and probably burn out your phaser coils to even do a reasonable amount of damage to make it uninhabitable. To destroy the planet, I think Kirk's mirror twin says it would have taken at least 4 starships to completely disintegrate the planet. And of course, the Doomsday Machine destroyed planets. Star Trek Phase 2, Evil Spock. Basically, they picked up from the end of season 3. They were trying to work all the way to the fifth and final season of Star Trek. But as I say, it was really one of those things. A lot more information was in some of the novels. Particularly, they were better during Roddenberry's lifetime. And it was a case of where he still had a reasonable amount of control. And that way he could say, no, that story is never going to wash. But a lot of the stories are either relate from either Picard's era or from DS9 or from Voyager's point of view now. So it's a case of they've really gone away. And I hate to say this, Star Trek Discovery really, really sucked because it completely blew out everything we knew from Kirk about the Federation Klingon War and Federation technology. Most of the starships were about maybe 2 or 3 generations more advanced than the NX-1. And even then, as they were pointing out, getting the Vulcans to give us technology was kind of like getting blood from a stone sometimes. They didn't want us to have it, but then once Vulcan gets threatened and they need the humans to help them out, then suddenly all the technology is available. But as I say, it's even Enterprise had issues with sticking to canon. They had time wars, they had aliens which weren't even known in Kirk's era.
Well, that would make sense.
And it was like, okay, where have the Zinti and all the others gone?
Oh, that's right. They were there, then they're gone later in time. Yeah, which doesn't make sense either. So
yeah,
yep.
So at least with Star Trek: The Original Series, when it came to a scientific context, Roddenberry made an effort. He had authors on board like Harlan Ellison, D.C. Fontana, Theodore Sturgeon, who knew their science. Because when they were writing their own books away from Star Trek, pre-Star Trek, they tried to make it as scientifically plausible as possible, to make it more believable.
Yeah, they still lacked a lot of practical science that they really should have had.
Yeah,
I thought in the original series, like cameras on the away team.
Yeah,
that could be seen by the bridge. Like I always complained about this. We could watch 1969. We could watch astronauts walk around on the moon. 22 blah blah blah. We can't see the away team from orbit. It's like I didn't accept that.
Hang on, Starstorm wants to say something.
All right, Starstorm.
Crossovers that could happen that you wish had.
Yeah, they had some good crossovers. Marvel had a crossover, had multiple crossovers with Doctor Who going to Picard's Enterprise. I think that was Sylvester McCoy, and no, it was Matt Smith. It was one. Tom Baker had a cartoon series, had a comic series where he was on board Kirk's Enterprise. They had the X-Men appearing on the Enterprise.
I never watched any Star Trek cartoons. I was like, I just don't do cartoons any.
Well, the animated series was they had the real voices. They had the original stars voicing it. Some of the stories were a little bit interesting.
Never watched them.
You should. They're really, really well worth watching. Even if only to say at least it's original Star Trek. And of course, there was a few stories there that were actually quite good, like Sharper Than a Serpent's Tooth brought Quetzalcoatl into this whole story because he was a space traveler who went to Earth. He became a god to the Mexicans, etc., and then left for a while. As I say, it's just one of those things. You could almost make it. It's almost believable because at one point he says, "Don't you recognize me?" Only one of the crew who is from that area realizes who it is, and he has to tell the rest of the crew that this is one of his gods from the old days. And some of them were good. The animation was jerky. The fact that they managed to get the original cast together to voice it was brilliant. I think that was really nice. They did actually completely remaster it. It was a little bit grotty on DVD, but they remastered it and put it out on Blu-ray, and it is very, very good. In fact, I think the thing is, a lot of people really got spoiled when they started putting Star Trek onto Blu-ray, because the nice thing about Blu-ray is you've got it in 1080p, and the explosions are much, much better. So is watching a starship in space, I suppose. And yeah, I have really gone over to Blu-ray in a big way. I like it. I love it. Because it really brings it back to being in a really ultra high definition cinema.
quick one before we move on.
Yeah.
What was your favorite and least favorite, sorry, of the original?
Sorry, what was that?
What was your favorite episode and least favorite episode of the original?
Least favorite episode? Oh, the one with Sharon. With
Sharon? What was that?
the guy with, I can't remember if it was Sharon or something. The guy with the two halves, two different coloured halves to his face.
Oh, with Frank Gorshin?
Yeah.
Okay.
I think my ultimate, well, it's very hard to say because there's at least 3 episodes amongst my favourites. Mock Time, because we get to see more of Vulcan and get to know more about Mr. Spock and his people. A piece of the action was very good. I just loved the way Kirk turns the tables and goes all gangster on them.
Mm-hmm.
So I think that has to be one of them. And I think for the third one, Day of the Dove.
What was that one about? Is that when...
That's when you have Klingons and the Enterprise crew fighting under the influence of an alien intelligence that lives off aggression.
All right. Gotcha. Remember that little sparkly floating thing.
Yeah.
All right.
And they all gather together to mock it and drive it out. Now, like the Klingons finally says, we don't need an excuse to hate humans, but today we will not fight them.
My least favorite one is the Empath.
Yeah.
I think I was like not watching it all that often, but every time I turned Star Trek on, it was the Empath episode. It's like I was so sick of that episode. Can't stand it. And the one I liked the best, I can't remember the name of it now. It's where they first meet the Romulans.
That would be A Balance of Terror.
A Balance of Terror. Yep.
They've got Leonard play. They got the guy who was playing Surak, who's going to play Surak, not Surak, Sarak, playing a Romulan commander aboard a Warbird.
Yep.
Totally Roman.
Yep. Well, that was kind of like a World War II U-boat type of.
Yeah, it was, and that was really.
Which way I liked it.
Yeah. Yeah, I think the other episode I really, really loved was Plato's Stepchildren.
Oh yeah, it was okay.
Yeah, I think in some respects one of the reasons I loved it is because it challenged the mores and attitudes of the time.
Mm-hmm.
And I think that was perhaps one of the greatest things Star Trek has ever done, is that it does challenge our attitudes in the present to how we deal with things. Star Trek gave us a hope that we could have a future free of tribal hatred. And the reason I say tribal is because, end of the day, everybody says, oh, they're a different race because they're Chinese or they're whatever. We're not. We're one species. We're Homo sapiens. You skin a human being from China, from America, who is white. We're all the same underneath. All it is a skin and biological adaptation to climate. That's the only difference between us. Our DNA is 100% the same. Mm-hmm. We are not separate races. We are one race. We are one species. And that, I think, is the greatest thing Star Trek gave us, is the hope that we will go out into space as one united planet and one united species.
All right, let's move on.
Yep.
Some astronomy stuff.
Yeah.
Did anybody out there? Well, everybody I think is Western Hemisphere, but anybody out there even watch the eclipse online?
Agreed, Red Shirt 3.
That was about 5 hours ago, I think, from now.
I actually had a report from my mother about it, and she says, clouds.
Clouds, yep, that's what I heard from
more clouds.
Okay.
Even more clouds.
Yeah, cloudy,
Went upstairs, went downstairs, went on the landing. Not a chance.
Heard from some people in Australia. Some had clouds, some had clear. Did you watch it? You're probably working, right? Like I was.
I was working, yeah.
Yep. So
I got in enough trouble for watching the last eclipse online at work.
Yeah.
Even though I was streaming it on my phone at the time and killing my phone.
I haven't pulled up any articles on it yet to see if it was extra dark or anything like that. So we're gotten any pictures from it yet. So, well, they'll be more forthcoming, I'm sure. So,
Well, I tell you what, let's go really massively black hole. Let's live up to the name of the show.
a
Shall we?
black hole article.
Black hole story. Yes, a black hole story.
We can do that.
We can always do that. This is from the European Southern Observatory.
Okay.
So basically the article is, the links are in chat. This is the first successful test of Einstein's general relativity near a supermassive black hole. This has taken 26 years of ESO observations of the heart of the Milky Way. This was published on July 26, 2018. Now, observations were made with the Very Large Telescopes the VLT have for the first time revealed the effects predicted by Einstein's general relativity on the motion of a star passing through an extreme gravitational field near a supermassive black hole in the center of the Milky Way. Now, this has taken 26 years of observations using telescopes in Chile. So basically, as we all know, the center of the galaxy is obscured by thick clouds of absorbing dust. And of course, our nearest supermassive black hole to the Earth lies 26,000 light years away in the center of our own galaxy. This is a gravitational monster. It has a mass of 4 million times that of the Sun. It's surrounded by a small group of stars orbiting at a high speed. This extreme environment, the strongest gravitational field, makes it the perfect place to explore gravitational physics, and more importantly, to test the general theory of relativity. Now, new infrared observations from the extremely sensitive Gravity 1, Symphony, and NARCO instruments on ESO's VLT have now allowed astronomers to actually follow one of these stars called S2 as it passed very close to the black hole during May 2018. Now, at the closest point, this was a distance of less than 20 billion kilometers from the black hole and moving at a speed more than 25 million kilometers an hour. That's 3% of the speed of light.
Mm-hmm.
So, yeah, it is very fast. Now, the team compared the position and velocity from Gravity and Symphony, respectively, along with previous observations of S2 using other experiments. Now, the predictions of Newtonian gravity, general relativity, and other theories of gravity, the results are now completely inconsistent with Newton and the predictions that Newtonian gravity predicts, and an excellent agreement with general relativity. So, thumbs down for Newton, thumbs up for Einstein. Now, the precise measurements were made by an international team led by Reinhard Grenzi of the Max Planck Institute for Extraterrestrial Physics in Germany, in conjunction with collaborators from all around the world. At the Paris Observatory, the University Grenoble-Alpes, CNRS, the Max Planck Institute for Astronomy, the University of Cologne, the Portuguese Centra, which is the Centro de Astrofísica e Gravitação, and ESO. So think about this. These observations have been going for 26 years without a break. Now, in fact,
I've been going a lot longer than that. So go ahead.
Okay, but have you been watching the same star go whip around a black hole that long?
Well, there's this floater in my eye I've been watching for about that long.
Anyway, this is the second time that they've observed the passage of this star. And the important thing is, because of as the years go by, our instrumentation has been improving. So we've had unprecedented resolution. But they were preparing for the event over several years, and they wanted to make the most of this unique opportunity to observe general relativistic effects. The new measurements clearly reveal an effect called gravitational redshift. So this is where the light from a star is stretched to longer wavelengths by the very strong gravitational field of the black hole. And the change in the wavelengths from S2 agrees precisely with how Einstein predicted it in general relativity. Now, this is the first time this deviation from the predictions of simpler Newtonian theory of gravity has been observed in the motion of a star around a supermassive black hole. So when you think about it, this is as groundbreaking as the first detections of gravitational waves. It's just one of those things that I don't think 30 or 40 years ago they would have said this was going to be seen. The only person who thought and said it would happen is Einstein. This is a man whose entire theory was a thought experiment, and based on general observations of things terrestrial. He noticed how things affected in a lift, how sound and lights affected it by speeding vehicles.
So what's different between Newtonian and orbits and this one is that Newton figured out that by math that if you have a certain amount of mass in the middle and you've got another object going around it, you can pretty much predict how long it will take that object to go around. Now, Einstein came up with, if it's really massive, there's going to be some time distortion so that Newton's math doesn't actually add up the same as what's observed. So that supermassive black hole is actually distorting time around it, and that changes the amount of time it takes for the star to go around it.
Well, it's not just distorting time; it's distorting space as well.
Yes, space-time.
Yeah,
it's everything. So just having it go around in a specific time, like everything else does, doesn't happen when you start increasing the mass, the amount of gravity in the center of the system. Well, it's like Mercury's was a little off on its predictions too. Newtonian physics said Mercury should take a certain amount of time to go around the sun, and then Einstein says no, that sun's gravity is distorting time and space, and it should take a different amount of time. And then the observation actually proved it. Yes, Mercury does not go around the sun at the time it should by predictions, unless you calculate in Einstein's distortion of time and space.
Well, this is, again, where doing transits of the planets has helped, because, again, this is something else that helps us prove Einstein's theory of general relativity. Because we are expecting to see result A, but we're not seeing that. We're seeing result B instead.
Yep.
And in some respects, the important for this really is this is going to help us. Everybody go, oh yeah, wouldn't it be nice to have a warp drive? Well, you know what? First off, we need to figure out exactly how the universe works. If you want to go beyond the speed of light,
you need to not know your calculations are going to end you up in a black hole.
Yeah, there's that, as you said, Starstorm. But there's also the thing is you have to work out how the universe ticks. And general relativity, although it is really helped. Well, let's face the fact: Einstein and quantum mechanics never got on. But maybe in the future, there is going to be an eventual marriage between relativity and quantum mechanics. Eventually, they're going to come together, and we will have a grand theory of everything. And I think this is what a lot of physicists are beginning to finally work towards: a theory that will bind not only the macro universe, but the micro universe, bring in everything and lock it all together in one theory. And even Einstein couldn't get to that point yet. But maybe he's actually finally given us the tools, because we're proving everything that he has said to be right. We're now going to have the tools in order to do this. And maybe once we have one grand theory of everything, maybe, I'm not saying we will get to the point where we can perhaps break the light barrier and maybe sidestep into another universe to travel travel at faster than the speed of light and finally get somewhere without having to wait X number of generations to do it.
Yep. But it doesn't seem like we'll actually do it by propulsion method.
Well, that we don't know.
Pushing something to the speed of light doesn't seem possible, so we're thinking that there's probably, like Star Trek-y, there's probably a different method of getting things to go faster than light, but not by propulsion.
Well, maybe it's going to be an Einstein-Rosen bridge.
There you go.
But we just don't know yet, because everything really is in its infancy. The first steps in infancy were taken with Einstein's theory of relativity. Now we have to build upon it, and this is the important thing. Every new discovery is built on what was previously known. Sometimes we end up discrediting a theory because we now find a better theory that fits what we're seeing. But that is life. Literally, that is life. That is science. Yes, exactly. Thank you, Starstorm. Hi, Uptronics. Glad you can make it.
Let's do a little station identification. Yeah. You're listening to the Event Horizon here on Astronomy.fm radio. It is another Friday evening, and this one happens to be July the 27th, 2018. A little bit past 9:30 in the evening for those of us here in the eastern portion of North America. So that would put it for Universal Time of about 1:30-ish in the morning, Saturday morning, July the 28th, again, 2018. So we're halfway through our program. Still got another half hour to go. And don't forget, we got more programming coming up after the Event Horizon, so stick around. We do everything in 4-hour blocks, so you'll be able to catch us in the repeat with our other programming, too, if you're you might miss part of our program right now, so you can catch us a little bit later. Of course, right now, while we're live, we have our chat room open. Just go to the home page. You'll find a link for our chat room. And see, so far we've got in you and me, and Aqua for you, and Glenn, and Starstorm, Twist Edge, Cassie, Evil Spock, Redshirt 3, Optronics, and Richie in our chat room. If you have any questions for us, come on, join the chat room. Type them in, especially like right now is good when we're really looking at it. And we'll try to answer your astronomy questions as best as we can, or Star Trek questions, depending on where the conversation's digressing to.
One thing I want to say here, on an astronomical note, if you want to see Pan-STARRS S3, I would get.
That's a comet.
It's a comet.
Yes.
I would. I would start looking. It's actually dimmed.
It's dimmed.
It's dimmed.
How bright did it get?
Well, it got. Some people were saying it was up to about Mag 7 or Mag 8. And it's
really?
Gone dimmer. It's gone back down. Now it did have an outburst, but as it heads into its appointment to go around the back of the sun, it has dimmed a lot.
Okay.
So make the most of it, because there's now a lot of people beginning to think S3 may not survive.
Okay.
It may not come out the other side. So if you have a chance to either observe it or to image it, I would take it now. I've got my image. I went to one of my favorite remote telescopes. I got some multi-luminance images of it, and it is looking an awful lot dimmer than it has been. I've been looking at some very fantastic pictures, but it has dropped an awful lot. So this is literally going to be, get yourself in gear, get looking at it, get your image if you want it, because I don't think it's going to come out the other side of the sun. It may completely and utterly surprise us all, but right now there's a lot of people thinking it's a goner, and it's also on a hyperbolic course. This is literally a once in a lifetime comet. Once it's gone, it is gone.
Oh, just by its orbit.
Yeah, its orbit.
It survives back out into deep space.
It's actually going to leave the solar system.
Yeah.
It's on a hyperbolic course out of the solar system, so it's been perturbed. It's come in. It's put on a really nice display. It's dimmed. It's going to go it's going to go behind the sun. It may or may not survive, but if it does, you better grab it quick, because it is never going to come back again. It is not like Halley's Comet, which is a periodic. It is not like any of the other famous comets like Kohoutik's, Enki rather, or West. West is a strange comet. It's never been recovered, to the best of my knowledge. It was lost in, I want to say, in the late 70s. It was predicted, and
I think it peaked around 74.
Yeah, but then its next apparition, it was never found.
Okay.
So it's one of those, and it's a periodic. It's not a hyperbolic, but it may just be a dusty old cinder somewhere floating in space now. Yep, it's flowing. Yes, it's going to follow that. And we're finding more and more of these objects that have come in from deep space. Jupiter has certainly captured one. They believe one of the Jupiter family is actually one of these deep space objects that got a little bit too close to Jupiter. and of course it's been captured. Now it shuttles in a regular orbit, and it puts on a little display every now and again, and it's there. Of course, the other good one is, of course, SW1 29p Swakman Wachman.
Swasman.
Whatever. Potato, Marty.
Sorry is serious.
There's a comment. So, would we become spaghetti people during FTL? Well, it depends. If your ship is cocooned in a piece of real space, whilst you're traveling faster than light, you shouldn't do. But you will become spaghetti if you cross the event horizon of a black hole. That is preordained.
Well, it says, predictions say it should still be fairly high in the morning. So,
Yeah.
but you said it's dimmed down a little bit, though, huh?
Well, as I say, the last predictions on the Sky Live had it at magnitude 11.
11. Oh, that's pretty dim.
That is getting dim again. Yes.
Yeah. Okay. Not a good one. It's first discovered around 13th.
21p Jacobini Zinner is putting on a nice little display. That's a good one. Like I say, S3 we discovered, we've talked. M1, I think I imaged that a few months ago.
Not visible from the north, only the south.
Yeah, so you got to remote into places like Siding Springs or Chile.
Yeah, it's like in the constellation. Well, it was in Ara. I don't know where it's at now. Let's look that up.
And of course, N1. Let me see. Maybe let's pull up the Sky Live because
T3 Atlas. Is that still reasonably bright? Do we know?
Yeah, I'm just going to look that up now.
Okay. Yeah, one of my Chasing Comets Skyhound.
Yeah, I actually use that a lot because I actually use Skyhound software.
Okay, not visible in the north again.
Sky Tool, yeah. Okay, so we got S3, which is magnitude 11 in Auriga. T3 is in Puppis at magnitude 11.3.
Well, that's dim
M1 is at 11.6 in Norma. 48p Johnson is at 13.2 in Aquarius. And a good old 21p Jacobini Zinner is currently 13.3 in Cephas.
Well, that's pretty dim.
But it's doable.
Well, photographically, yes, but
imaging, yes.
Visually, no.
Yeah. Let's have a look. N6 Penstars is a whopping 13.4 in Cancer. I'm just trying to see if N1. Oh, here we go. SW1 14.5 in Pisces.
That's pretty dim too.
Yeah.
All right.
Atlas is at 15.2 in Hercules.
Lots of comments, but nothing really visible.
Mm-hmm.
Even though some of them have flared up not too long.
S3 actually made binoculars very easily.
Oh, well. Dark skies.
Dark skies. And, of course, Hayabusa descended to make a closer inspection of its asteroid target as well. That was last week. Let me just pull up a link for that.
Oh, yeah. I forgot about that. That was from JAXA, Japanese space agency. And that went to, what was the name of that? Hayabusa was the probe.
Yeah.
And what was the name of the asteroid it went to?
Oh,
that's right. Ryugu. Yep. I've for some pictures of that recently. So
as of the week of July 16th, operations began to lower the hovering attitude to bring the spacecraft to less than 6 kilometers from the asteroid surface. And there is a very nice picture of the rock-strewn surface of Ryugu.
Is that in our chat room yet?
That's the link in our chat room.
All right, there. All right.
Oh, and by the way, I understand I'll be getting down to about mag 17 when I get the DOB with a CCD or a DSLR.
Definitely much closer than we have seen in the past. The last time we talked about it, looked at it. So you can just type in JAXA, JAXA in your search, and add maybe space or something like that to you.
I think it's the deep space travel is Amurura. That's the closest I can get to it.
Okay.
I made the attempt. So I'm getting.
We're not there. We're not there yet. My clock's off. All right, let's see what else we got. Let's do a quick around what's up in the sky. Mars at opposition. We forgot about that. That's tonight. Or, well, actually, technically yesterday. Last night it was at opposition. So still pretty close. Have you looked at Mars?
No, I haven't, because the last few days I've had rain, thunderstorms, rain, clouds.
It was about a week ago or so when I looked at Mars. It was definitely pretty big. You can definitely tell it's much, much closer to us, but still almost no detail on Mars at all. There's a Hubble Space Telescope picture of Mars and Saturn also, so some pretty nice new images. Saturn looks awesome. Mars, mediocre.
But then again, even with the great desert, the great sandstorm that's going on right now, there's still stuff that's being done, and certainly the space probes around Mars right now are really going into overtime, and particularly where you've got LiDAR radar available, they're actually plumbing into the depths of Mars, and they found at the South Pole could be quite a large briny lake. So that was not expected, and these guys who looked at and found the information, they really did treble check their results, because the last thing they wanted to do was say, "Hey, we found water on Mars," and then 3 weeks later go, we were wrong.
It was a painting of water. It was just a mirage.
Triple check, double check, quadruple check.
There you go.
They would have really checked their results and had them peer checked as well. Because that way, at least, they know that when they actually put their hands up and says, "We think we found water on Mars," it's pretty much, yeah, we think we found water on Mars. It's briny. It's under the South Pole. It is deep underground.
Salt water.
It's
under ice. Oh, it is under dirt.
It's actually under rock. Under the crust. I think they said it's about a mile underground or something.
That's pretty deep. I just wonder if it was a mile underground under ice or under dirt or rock.
No, it's actually, they believe it's actually under the rock itself.
Okay.
So yeah, it is kind of fascinating. Yeah, let's use the word fascinating. I like that word.
I've got another black hole article.
Yeah.
Let me throw this one out here. We click on it and copy into our chat room. Here we go. It's an article about black holes being where did it go? There we go. Actually forming on the outskirts of spiral galaxies, and they could be some pretty big black holes too. So it's thought that black holes could form in the outskirts of the galaxy. Big, they say massive, but I think they mean massive as far as stellar-sized black holes go, because the outer edges of galaxies, kind of like in dwarf galaxies, rather metal-poor stars, so they're mostly hydrogen, and because they're metal-poor, they tend to be able to coalesce much easier when they get lots of metal in them. The metal combines quickly, kind of overheats everything, and kind of blows the gas away, so they can't form very big. But in the outer regions of the galaxies, they're able to collect much more gas together and keep it together, so you end up with bigger stars in the outer portions of spiral galaxies, along with dwarf galaxies. And if you have a lot more large stars, that means a lot more, they're going to burn up a lot faster and explode a lot more. And if there are a lot of really, really big ones, that means more black holes. So you could have the galaxy could be circled with a lot of pretty big stellar black holes.
Yeah, they're certainly not simply at the center of galaxies. We do know that there are quite a few that are just aimlessly wandering around the universe.
Yes.
Occasionally consuming the odd star or big chunk of gas. We can see them again through something predicted by relativity, gravitational lensing. And that is the only way we can actually detect these rogue black holes, if so to speak, is by literally how they bend light around them. And again, this is something that shows us how good Einstein really was at describing the nature of the universe.
Yes, indeed. Got 4 alert notices from the AAVSO, American Association of Variable Star Observers. The latest one is about a star called FO Aquarius.
Got a link, Marty?
Oh, yes, indeed. Let me put this up here. There we go. Right there. I got to go back to it. Where did it go? There we go. So this is just one of them. This is the latest one. They want some observation of this. It's thought that this star is a 2-star system, binary system. One's a white dwarf. The other one a low mass, a small companion that's drawing stuff off of it, and it's going into orbit around the white dwarf. And it seems that as it forms an accretion disk, well, sometimes it loses that accretion disk and then gets it back again. So they're kind of wondering what's going on, what's keeping the accretion disk there, what's drawing it away. So they want people to do some observations of this star to try to figure out. And I said, go to the Association of Variable Star Observer. There's actually some more stars right now that they want observed. There's some red dwarf stars they want observations of. I can't remember what else.
But no, I think the thing is, in a lot of respects, amateur astronomers, and you know what, I'm going to define what an amateur astronomer is. An amateur astronomer is something who has the knowledge and the skills of a professional astronomer, but is not paid for the job.
Mm-hmm.
Now, it used to, in modern language, an amateur is someone who basically bodges it and may not know what the heck they're doing. Amateur astronomers are a different kettle of fish. We are proper scientists in our own respects because we know how to image, we know how to process, we know how to report our observations and keep scientific logs. So we are just as good, just as knowledgeable in a lot of cases as the paid professionals.
And we have the time and equipment.
And yes, as you've quite rightly pointed out, Starstorm, we have the time, we have the equipment. We have equipment today that is the envy of most professionals. They have to buy time on big scopes. They have to justify why their proposals should be granted time. We can go out.
Just as good big telescopes.
We can go out on not every night of the week if we wanted to. When it's clear skies, we can image, we can observe, and we can do a lot of the footwork that these guys and gals need. The best thing about it, I suppose, is yes, we are at we're just as good as they are. We just don't get paid for it. So we're not budgets. We are actually just as good as amateurs. But the only reason we are amateurs is because we're not paid.
Mm-hmm.
You said amateurs twice.
Yes, I know.
You said amateurs where you meant to say professionals.
Okay, we're not, unlike professionals, we are not paid. We're amateurs. We do it as a hobby, but we have the knowledge, we have the skills that they do. And to be honest, I would like to see some of these professional astronomers actually star hop. Believe it or not, a lot of professional astronomers haven't got a clue.
Can you star hop?
I can, yes.
Ah, very good.
Thank you to Mr. Google. I haven't had to star hop in a very long time. I bought a go-to telescope. Yeah, I got very, very lazy very, very quickly.
Couple of novas/supernovas discovered, about 11th magnitude. Let's see. One is in the Pelican Nebula, just north of Cygnus, and the other one I didn't find out what constellation it's in, but it's at 11 hours 38 minutes and plus 3 degrees. So again, about 11th magnitude. The only thing we've got for reasonably bright novas, supernovas right now. So it's all of them are 16th, 17th magnitude, something like that. So it'd be nice to get some more bright supernovas.
Solar sphere.
In the galaxy. Yes, solar sphere. Run through this one really quick. Coming up August 10th through the 13th. And where's that at, Nick?
It's in solar sphere's in the UK.
Well, definitely in the UK, but do you know exactly where in the UK?
Yes, I do. Okay, I'm just trying
Shropshire?
I'm pulling this up. Location. It's it's next door to the Royal Welsh Showground off the A470, 2 miles out of Blwyth, Wales, on the opposite side of the river to the town of Blwyth. Now, keep in mind that if you're using a sat nav to get there, it's going to take you to the private entrance of the farm. So don't enter that way. There will be a solar sphere sign directing you to the official campsite entrance. It's at Penmeadow Farm, which is right next door to the Royal Welsh Showground. It's actually a lovely area.
So this is by the way, it's an astronomical and music festival combined together.
And it's a sci-fi party too.
All right. We're planning on getting Pete Williamson from the that's presenting this for an interview, and we'll get it together before the actual event. So stay tuned to that. Nick and I are working out the details to get recording of Pete tell us all about solar sphere and everything he does with his astronomical imaging and stuff like that too. So a little bit of music talk, I think.
Yeah, he's also a heavy metal band member. The group's called Anubis. They're actually quite good, actually.
Sounds good to me. Yes.
But yeah, it's actually a good event. Actually, Mary McIntyre from Comet Watch is going to be there this year. She's giving some talks, and I think she's talking about sketching at the telescope.
Mm-hmm. Tess.
Tess?
Yeah, there was a Tess from Star Trek. Remember Tess? Voyager from Voyager.
Oh yes, that's Voyager. That's
well. Anyways, Tess is also a exoplanet hunting satellite, and it's actually starting its science operations now. So it's going to be scanning stars for varying brightnesses, and it's actually in a very elliptical orbit around the Earth, passing close to the Earth every 13 days, and that's when it'll download its data. In the meantime, it's scanning. It's got 4 cameras, scanning as much of the sky as it can, and we'll see if it picks up some variabilities in some stars and possibly discover some more exoplanets.
Tess. I remember where I know Tess from. Tess Fontana, Jack Carter's ex-girlfriend in Eureka.
Oh, that was those are awkward episodes.
Sorry, it's just you saying Tess. I mean, where do I know Tess from? Thinking about, and the Tess I remember. You're thinking of Kess, aren't you?
Was it Kess from Voyager?
It was Kess in Voyager.
Oh, yes. I thought it was Tess in Voyager.
Yeah,
okay,
but no,
maybe it's Kess.
Tess was Tess Fontana, who was involved with a spacecraft coming home and keeping it a secret from the sheriff and a few other people.
Ah, okay.
Yeah.
Just a couple more minutes. We've got the Parker probe is going to be launching hopefully within the next couple of weeks, or maybe just a little bit after. So something to look for. It's going to go into a close orbit around the sun, about 4 million miles away, I think, from the sun, something like that. So it's going to go through the solar corona and figure out why is that corona so hot? Why is it 2 million degrees in the corona, and then just below that, close to the sun, it's 10,000 degrees.
And of course, everybody's going on about, oh, where are we going to find Vulcan at last? No, there's no such thing as Vulcan. Certainly not in our solar system.
That's right. There's a whole hot time in the old town of Vulcan tonight.
Yeah. There's desert atmosphere, high altitude, as I remember from my Star Trek. But though Vulcan was a planetoid, everybody thought was between Mercury and the sun.
Yeah.
And it doesn't exist.
Probably when optics weren't so good, it was a small sunspot that stuck around for a while.
Vulcan exists around Eridanus Eridani, not close to the sun.
Mm-hmm.
Just need to qualify that question in the chat.
The original Vulcan.
I'm waiting for a planet called Gallifrey.
Well, you know what's about to happen now, don't you, Marty?
I think so, Nick. It's time to call up
Captain Savik. The away team of Starstorm, Nick, and Marty is ready to beam up. Bring us home. We've got the paleontological samples and the meteorite samples.
Thanks for listening, everybody. Appreciate you all being those that were in chat with us tonight. And we'll see you again next Friday. Good night, all.
Good night, everyone. Live long and prosper.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my